On scientific notation. Scientific notation is like an abbreviation for numbers. It's something you use when you have really big numbers and really small numbers, so you don't have to write a whole bunch of zeros after it or before it if it's a really small number. So the way it is done is that it is used by using powers of 10. And it is the product. That means you're going to multiply. Product is answer to multiplication of two factors, one greater than or equal to 1 and less than 10, and the other is a power of 10. So if we are writing in scientific notation, we're going to move the decimal point until you have a number between 1 and 10. So basically, you're going to make sure that your decimal point is between the first two numbers. The number of places a decimal point has moved becomes the power of 10, because you know every time you multiply or divide by 10, you move your decimal point one place. If the decimal point is moved to the left, that means you had a big number and you're moving it to the left, the exponent is going to be positive. If the decimal point is getting moved to the right, that means you have a really small number with a lot of zeros in front. Your exponent will be negative. So here's an example. This is a really big number. We want our decimal point between the first two numbers here, because that number will be between 1 and 10. So it'll be 4.76 times 10, and then we moved our decimal point. It started here, 1, 2, 3, 4, 5, 6, 7, 8, so it's times 10 to the 8th power. If we have a really small number now, you can see that we're still going to put it between those first two numbers, but our decimal point is going to be moving to the right. So it's going to be 4.76 times 10, but now it's moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be to the negative 10th power. Now, if you want to convert it to standard form from scientific notation, then we're going to be doing the reverse, right? So the exponent of 10 tells you the number of places you need to move your decimal point. So if the exponent is positive, then you're going to move your decimal point to the right, because it's going to be a big number. Your number is going to get bigger. If the exponent is negative, you're going to move that decimal point to the left, which means it's going to be a smaller number. Okay, I'm going to give you some problems to do, and then you're going to be able to check the solutions on the video after you do the problems on Edpuzzle. So this is a solution for those problems you just did. We have 1.315. This tells me right here that I'm going to move my decimal point 10 places. So 1, 2, 3, and then we're going to have to add 7 zeros. So it's going to be 1, 3, 1, 5, and then 1, 2, 3, 4, 5, 6, 7. We put commas every third. 1, 2, 3, 1, 2, 3. So you can see it's a really big number. Number 2. This time the exponent is 3. We're going to move our decimal point 1, 2, 3 places. So it's 6, 8, 0, 0. Number 3, see how it's a negative 10? That means it's a very small number. I don't even think I have room right there, so I'm going to write it down below. I'm going to move this decimal point 1 place, but then I still have to move it 9 more places. So I'm going to have 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it's going to be 1, 3, 1, 5. Very small numbers. Those are the kind of numbers that people use when they use a microscope and they're measuring very small, very, very small units. The big units are things like when you're measuring the distance to planets and stars and you have really, really big numbers. That's when you use scientific notation. So this one here, again, is a small number. It's a negative, so that means this decimal point is going to go 3 places this way. We're going to have to add 2 zeros, so 0.0068. And those are the answers. Scientific notation is very handy when you have to write scientific reports. and are dealing with very big numbers.